All right, we'll get to some classwork here in just a moment. First, I want to review with you over some things we've been working on lately. What is the instrument we use to measure angles? The instrument we use to measure angles, Ben?
Protractor.
Protractor. What is the instrument we use to construct equal angles? Instrument used to construct equal angles, Corey? Compass. What's the instrument we use to construct circles? Instrument used to construct circles, Sam. Also the compass, very good. As we draw circles, a circle is different from all the other closed curves in that all the points of a circle are the exact same distance away from one fixed point. What is that fixed point called, Luciana? The center. Remember, the name of the center, the capital letter used to name the center, is also the name of the circle. For a circle, if you were then to measure that fixed distance from the center to any of the points along the circle, that line you would draw is referred to as the radius of the circle. What about a line that starts and ends on the circle? Rather than starting at the center going to the circle, that'd be a radius, starting and ending on the circle, we would call that, Kirsten?
A chord?
A chord. Now, we could also draw a chord so that it goes through the center. What do we call a chord that passes through the center of a circle? Bryson? Chord that passes through the center. Diameter, good. You picture a circle, picture a line starting and ending, but going through the center is a diameter. What's the relationship between a diameter and a radius? Relationship between diameter and radius. Jalen?
The radius is half of the diameter.
Radius is half the diameter. What's another way she could have said the same thing, Elaine?
The diameter is double the radius.
Diameter is double the radius. Either way you want to look at it. When it comes to constructing circles, if I tell you the radius, how should you go about constructing the circle? If I tell you what the radius is, what should you do? Griffin?
Use a ruler or something and measure out. Draw a line to a distance you need and extend your compass to that distance, and then put a little arc at the end of that line, just so you know it's right. Then you draw the circle.
There we go. Draw a line that's equal to whatever the radius is supposed to be. Measure it off carefully with your compass. He even gave the extra detail. Make that little arc mark when you measure, just to make sure it's right on. You didn't think it looked right, but it wasn't quite. And then draw your circle. Remember, when you draw the circle, you should really only be holding, class, what part of the compass?
The pointer.
The pointy part of it. Put your weight there. I also suggested you hold the compass at a little bit of an angle and then pull the paper from behind the compass to get a nice smooth circle. What if I told you the diameter of the circle and you were supposed to construct a circle based on that diameter? What would you have to do, Luciana?
Split in half.
Split it in half, right, to figure the radius, because your compass can only construct or measure out radii. What do we call a portion of a circle? If instead of drawing a complete circle on your paper, you just drew a part of one and then stopped before you got all the way around, Corey, we would have an
Semicircle?
possibly, but that's very specific. A semicircle is specifically how much of a circle?
1/8. Wait, half?
It's half the circle, right? So if I started and stopped exactly half a circle, that would be a semicircle. But in general, just any part of a circle. I just draw however much I feel like. It doesn't necessarily have to be half. We would call that an Jalen? An arc. What do we call it, Corey? An arc. Any portion of a circle is referred to as an arc. How do I indicate, for instance, if I had a circle here, pretend that's a circle, I know it doesn't look great, but let's suppose I had this angle here, and I had this point A, this point B, we'll call the circle O, and I could also draw a line from A to B. Well, OA, class, that's called a radius. OB is called a radius. What is AB called again, class?
Chord.
A chord. But AB could also be this arc. How do I indicate I'm talking about arc AB, Bryson?
You put a curvy over.
Good, put a little curvy over it. Well, how do I show that I mean chord AB, Bryson?
You put a...
Kirsten?
Straight line.
Just put a little line segment marker over it, right? That little line just means line segment. So that's how we'll differentiate between chord AB and arc AB. Now, these two radii come together at the vertex. and it forms an angle. Yesterday we talked about these angles. What do we call an angle formed by two radii with obviously then the vertex at the center? Michael? A central angle. Class, what do we call this angle here?
A
Central angle, because its vertex is at the center. And of course it's formed by a pair of radii. Now, if I wanted to measure this with my protractor, I certainly could. I might measure it. It looks like it's about 62 degrees, for instance. If the angle AOB is 62 degrees, what else must be 62 degrees? From our lesson yesterday. What is always equal to a central angle? The arc that it intercepts. It cuts off arc AB. Arc AB must also be 62 degrees. What if I drew another angle here? And maybe this is 87 degrees. And let's call this OC. Well, if angle AOC is 87 degrees, then class, we know that
The
arc, which arc?
AC.
Arc AC must also be 87 degrees. If I drew another radius here, OD, and that maybe forms a central angle of, I don't know, 41 degrees. Well, if we know that angle COD is 41 degrees, then class, we also know that arc CD is 41 degrees. We know that arc CD is 41 degrees. How big is angle DOB now? How would I need to find that? Elaine?
So you add up 41, 87, and 62, and whatever that is, you subtract that from 360.
Good. Remember that the total, the sum of all these central angles has to be what, class? 360. So, at your seats, find angle DOB. At your seats, go ahead and find angle DOB. Call it when you've got it, class. 170? Yes, 170 degrees is angle DOB, which means that arc DB, then, class, is also 170 degrees. Questions on this stuff we talked about with the circle? We also talked about a lot about triangles in the not too distant past, and when we talked about triangles, we said there's all different kinds of triangles. One of the triangles we talked about was a scalene triangle. What's a scalene triangle, Corey?
Triangle with no equal sides.
Triangle with no equal sides. We talked about another kind of triangle, we call it an obtuse triangle. What's an obtuse triangle, Griffin?
It's a triangle that has one obtuse angle.
What are the other two angles?
Acute.
Good. Triangle with an obtuse angle. We talked about an equiangular triangle. What does equiangular mean, Kirsten?
When all the sides or angles are equal?
When all the angles are equal. Equiangular. All the angles are equal. How big are all the angles then?
100.
Well, the sum is 180, right? So each of the angles has to be 60 degrees. We talked about another kind of triangle called an isosceles triangle. What's an isosceles triangle then?
It is the triangle with two equal sides.
It is a triangle with two equal sides. Smashing job. Let's see, what about an acute triangle? What is an acute triangle, Sam? All acute angles in it. We talked about another triangle called a right triangle. Yes, you're right. What is a right triangle, Jalen?
The right triangle is a triangle that has one right angle and two acute angles.
Good, a right angle and then of course two acute angles in it as well. We said this, that when you look at the sides of a triangle, the three sides, there will of course generally be, unless it's got all its sides equal, which we call that what, Bryson, if all the sides are equal? Equilateral. Unless all the sides are equal, one side will be longer than all the others, right? And if there is a longest side, there's a limit on how long it can be. It can never equal or be greater than what, Luciana? The biggest side of a triangle can't be bigger than, in fact, that matter can't even equal what?
The number of those two sides.
The sum, I think is the word you were looking for, the sum of the two littler sides, right? So the two littles have to add up to more than the big side. We also said, of course, that the angles always have to add up, Michael, to...
180 degrees.
So if you were given just two angles of a triangle, you got to make sure that the two of them collectively are less than 180 degrees. Good. At your seats, go ahead and have your textbooks to the side of your desk. Have the textbooks to the side of your desk. If you would, have your compass out, your protractor out, some blank paper out. And on your paper, I want you to measure a 2-inch radius. Measure off a 2-inch radius on your paper. Yes, ma'am. Page 172. And then set your book on the floor beside your desk. Measure, if you will, a 2-inch radius on your paper. Compass, protractor, paper. Books open to page 172, but beside your desks. Yes, ma'am.
Can I sharpen this one?
Yes, quickly. Yes, ma'am. What's the problem? Is it in pieces? Is it in fragments?
Oh, that's okay.
All right, so measure your 2-inch radius. I would just use, once you've got it measured, might as well just go ahead and keep the circle right here. So you measure it. Draw your circle so that it has a 2-inch radius. If you look beside your desk there, number 19, they want you to construct 3 central angles in your circle. They want you to construct a 150-degree angle, a 90-degree angle, and a 120-degree central angle. Of course, these 3 angles have to add up, class, to 360 degrees in the circle. So at your seats, go ahead and draw these 3 central angles in your circle. Once you finish 19, go on to number 20. And for number 20, I want you to use a diameter of 8 centimeters. Use a diameter of 8 centimeters. Should go all the way to the edge. On number 19, did we actually have to draw all 3 angles, class?
No.
No, as long as you draw two, I mean, you don't necessarily have to draw the first two, but as long as you draw two of them, the third one should take care of itself, assuming the first two were drawn correctly. What do I need to do about this 8 centimeter diameter, class?
Draw a line. Oh, cut it in half.
Cut it in half, right. It says 8 centimeters. We need to be thinking of a 4 centimeter radius. So it'll be a little smaller than the last one. If you're lazy, you get to pick an angle you don't draw, right? Which is probably the easiest, the best angle to skip. The biggest angle. That's what I would skip the biggest angle if I were trying to be lazy here. I'll just go ahead and go in order for consistency's sake, but again, since you don't have to do that. Once you got both 19 and 20 finished on your paper, go and do 21 through 25 there in your textbook. So once you're done with both of them, you look at your paper, you look at my board, and you're like, yep, that looks the same. Go ahead on to 21 to 25, answering those questions. If you're having some trouble putting together 19 or 20, raise your hand, I'll come by and help you. Somehow you have 5 angles instead of 4. Let's see what you did. Would help to have that way side, wouldn't it? You drew 30. Oh, okay. So when you draw your 30, you then have to rotate because your next angle starts here. Then you're going to draw your 80. Right, yeah, don't, because this is 30, this is 80. But that means this one's only 50. Does that make sense? That's what the problem is. Well, right, you keep rotating the baseline too. So let me show it again. So when I measure my first angle, I'm starting at my first radius that I drew. After I draw my first angle, then I rotate for my second angle. Then I rotate for my third angle. If there were a fourth angle, I would rotate again for my fourth angle. And that's in fact how we check to make sure it's 80. Does that make sense? All right, good. Anyone else having some questions, having some trouble? Like, it's not looking like yours, Mr. Nadasky. Something's not right. Alright. Okay, once you're finished with both, doing 21 to 25 there in your textbook. How did you manage that? I've never seen that in all my years. You're truly one of a kind. Use this for the day. No charge. You wanted metal ones. Yeah. There you go. You bought it. You were looking at me funny. Or it looks like you were looking at me. Anyone else needing help on 19 or 20? So you have a little, what? So you started with an 80? looks kind of small. Is that a 4 centimeter radius? Oh no, don't use that. What you want to do is actually draw a line on your paper that is 4 centimeters. Measure that. Do you see how big the radius was supposed to be? Yeah, it's just a little bit off, so. And then draw the circle. Now come over here to that. Okay, the next thing, when you draw your angles, you started by drawing a 150, right? And then you drew a 120 and then a 90 from the same spot. Well, the problem is, if this is 90 and this is 120, this little piece is on the third. This little piece is on the third. We want them to be all separate, not overlap. So once you draw the first angle, you're going to start here and draw your 90. And then you're going to start here and draw your 120, which will actually be back where you started. Does that make sense? So after you draw an angle, rotate to where you left off. Right? It's like if you ran, if you run to first base, then you pick up where you leave off before you run to second base, right? You don't have to start back from the beginning again and go to second, and then start from the beginning and go to third. You pick up from where you leave off, and then you go, right? So it's kind of like go to first, go to second, go to third, just picking up each time from where you left off. Alright, so first angle you drew was the 80 right here, correct? Okay, and then you rotated it. And you draw your 30. There's 80, there's 30, and you rotate it again. And there's your 80. And that should leave 170 for the last one. Does that make sense? Just keep rotating as you go around. All right, textbooks out. Go ahead and put your papers away at this point, even if you're not done with 19 and 20. Have your textbooks out, open at page 172. So go ahead and pull those up on your desk. Let's talk about numbers 21 through 25. I realize some of you didn't have an opportunity to actually answer the questions yet, but let's be following along as we go over it with those who did. Number 21 says this: if angle C and angle D are complementary angles, what does that mean, Kirsten?
90 degrees. It adds up to 90 degrees.
Add up to 90 degrees. And angle D is 45. What's the measure of angle C? Volunteer, Corey.
45.
Also 45 degrees, so a complementary angle that's equal to its complement. Number 22, what's the name of a triangle that has a 90-degree angle in it? Elaine?
Right triangle.
A right triangle. Number 3, how many vertices does an isosceles triangle have? Michael? 3. Does it matter that it's isosceles, class? No, that was a trick question. All triangles have 3 vertices. Number 24, what kind of angle is angle O if angle O equals 170 degrees? Ben?
I didn't get that one. I didn't understand it.
Well, what kind of angle would be a 170-degree angle?
Obtuse.
Obtuse angle. That's all they were looking for. Number 25, what kind of triangle has no equal sides? Jalen? Scalene triangle. There we go. All right. If you would flip back in your textbooks now to page 169, and I have talked about this for a couple days now, and we have yet to actually get there. Let's talk now about the term circumference. You see it at the top of the page, page 169. The circumference is the distance around, or you could think of it like the perimeter of a circle. We don't use the term perimeter. Perimeter means the sum of the sides. A circle doesn't have any sides. The circumference is the distance around a circle. Make sure you note that. Now, interestingly, class, if you were to actually, let's just say you were to put a little ant on the chalkboard, and the little ant were to start here, and it were to run all the way around the chalk, that would be the circumference, right? If another ant were to cheat, and were to go straight across the circle and back again, that would be cheating because it's shorter just to go straight across and back, right? It's longer all the way around. In fact, if you go across and back, that's 2 diameters. If you were to go all the way around, it's almost equal to 3. diameters. But not quite 3. A little bit more than 3. And there's a number we use to represent the ratio of circumference compared to diameter. And class, what is that number? What do we call that number? Pi. Now pi looks kind of like this. I've seen it a number of different ways. Hey, as long as there's 2 down and 1 across, I'm not picky what you curve and what you don't curve, okay? If you want to see what it really looks like, it's there in your textbooks. You see that there, the Greek letter pi. They kind of draw it with a little bit of a hook here and a little bit of a flare there. 2 down, 1 across the top. In fact, capital pi is in fact just like that. Straight hard lines. It's the lowercase pi that has a little bit of the inflection to it, a little bit of curve to it. But pi, lowercase, is how we represent the ratio of circumference to diameter. If you could measure how far the ant ran versus the cheater ran one way, it would come out to 3.14159, and it would just keep going and going and going and going. Never stop, never repeat, never end. We're only going to use this part of pi. If you were to try to make a fraction that's close to pi, it's not actually equal to pi, but close to pi, if you divide 22 by 7, you get 3.142857 repeating. Well, the first 3 digits are identical, and the 4th digit's really close. 22 sevenths and 3.14 are the approximations. Let me say it again. The approximations we use for pi. Now, because that's true, when I find the circumference of a circle, I'm going to be using an approximation. So when I get my answer, is it going to be perfectly accurate? No, it's going to be approximately equal to, because pi is approximately equal to 3.14 or approximately equal to 22 sevenths. Right there in the side margin of your book, all of that content is there in the paragraphs, but it'll be easier for you to see if it's off to the side margin or up at the top of the page or something. Pi is approximately 3.14, approximately 22 sevenths. Now, 3.14, 3 digits, decimal, kind of annoying. 22 sevenths, fraction, kind of annoying. Unless a number I'm trying to work with happens to have a 7 in it, right? So 22 sevenths has its place. If pi is defined as the ratio of a circumference of a circle to that circle's diameter, then the circumference must equal the product of pi and the diameter. And this is one of our 2 equations we use to find circumference. Another way we could find it is, well, what is a diameter? It's 2 radii, right? So if you double the radius and multiply by pi, that would also give you the circumference. Or, since algebraically we always put numbers first, c equals 2 pi r. You see this in the little box there where it says circumference. If you're given a diameter, it's pi times diameter. If you're given the radius, it's 2 times pi times the radius. Make sense? Though admittedly, I usually double the radius first because it's easier to multiply the radius times 2. Notice how we find the circumference of a circle. And by the way, how many say, I have found circumferences of circles in years past? We did this in elementary. Most of you did. Look at the blue shaded box. Look at the example problem. If the diameter is 4.8 centimeters, well, class, what's my first formula for circumference? Say it with me. C equals pi d. Again, C equals pi d. So the circumference equals pi 3.14 times the diameter, which it said was 4.8 centimeters. So notice they multiplied 4.8 times 3.14, and notice they got, well, what did they got, class? 15.072. But it's actually approximately 15.072 centimeters. Why is it approximately that? Because pi isn't actually 3.14. It's approximately. Even then, it said apparently they wanted to round to the nearest tenth. So if we round to the nearest tenth, class, we'll get approximately 15.1 centimeters, because the 7 bumps the 0 up. Questions on what they did on the first example? Look at the next example. This time they give a radius of 1 1/6 inches. Oh, 1/6? That's going to be a repeating decimal. What is the decimal for 1/6 class?
0.16.
Good, Jalen. 0.16 repeating, came in strong with that. But the 1 and 1/6, you can't multiply by a repeating decimal. So we're going to have to leave it as a fraction, aren't we? But if C equals, say, the second equation for circumference with me, class, C equals 2 pi r. Again, C equals 2 pi r. 2 times pi times r. Well, you don't multiply mixed numbers either, do you? So rather than putting 1 and 1/6 class, we should make it an improper fraction, 7/6. And since we have a fractional value here, and it's got a 7, I'm going to use not 3.14 class, but 22/7 for my approximation of pi. We can cancel the 7 and 7. I can cancel the 2 and 6 even class to get 1 and 3. Obviously 7 and 7 is 1 and 1. And so I end up with approximately 22/3, was it inches? Yeah, 22/3 inches. Or let's make it a mixed number, class. 22/3 becomes?
7 1/3.
It's about 7 1/3 inches around that circle. Do we see how to use either 22/7 or 3.14 as pi? All right, turn over then, if you would, to page 170. Flip the page, page 170. Look at number 27 with me. Which formula for circumference of a circle should I use on number 27? Bryson?
C equals RD, or pi d.
C equals pi d, because they give us, class, the diameter. Now, should I use 22/7 for pi, or should I use 3.14 for pi on number 27, Bryson?
3.14.
Yeah, I should use 3.14. There's nothing about 4 feet, right? It was 4 feet, class? Yes?
Yes.
Okay. That would cause me to want to use 22/7. So we just multiply. 3.14 times 4. Call it when you've got it.
12.56.
But we're going to say the circumference is approximately 12.56 feet. Did it say to round to the nearest tenth by any chance?
No.
It didn't, so we'll leave it as 12.56 feet. Look at number 29 with me if you would, please. Notice it gives me again the diameter. So I'm going to use what equation for the circumference, Luciana? C equals pi d. I'm going to multiply. What value should I use for pi here, class?
3.14.
Let's use 3.14. And we're going to multiply that by the diameter, which it said was?
6.
We're on number 29.
3.5 yards.
3.5 yards. And so we multiply by 3.5. And notice how many decimal places in the answer, class?
3.
3 this time. Extra seats. Multiply 3.14 times the 3.5. And what do we get for our approximate circumference, class?
Approximately 10.99.
10.99 yards. We don't have to write the last 0, though we should have included it initially in our decimal places. And we get about 10.99 yards. Now, the book says 3.5 yards, but a moment ago Jalen said 3.5 yards. That's the same thing, isn't it? What if, though? What if, instead of thinking of 3.5, what if she actually thought 3.5 and then thought to herself, hey, I should make this an improper fraction so I can multiply. What would the improper fraction be, class? 7 halves. Now this is only significant because of the 7. Because what's my other approximation for pi? 22/7, which if I do this, the 7s can cancel. For that matter, 22 and 2 can cancel, class, to give me 11 and 1. So what's my approximate circumference this time? 11 yards. Which way was easier? I think that one. Be on the lookout for numbers with 7s. In that case, it was really hidden, wasn't it? You had to think 3.5, 7 halves to find the 7, but it was there if you wanted it. Nothing wrong with this. Notice they're basically the same answer anyway. They're very, very close. Yeah, a couple ways you could have done 29. Look at number 30, or 31, excuse me. Look at number 31. Which equation do we want to use for circumference on 31, class?
equals 2 2 r.
C equals 2 pi r. Let's try it again. Say it with me, class. C equals 2 pi r. Again, C equals 2 pi r. And so, of course, I've got the 2. For pi, let's see, is there any suggestion of a 7 in 6.5 feet?
Well, yeah, you can, yeah.
6.5, 13 has, there's no 7s there. Okay, we'll stick with 6.5 then. All right, so 6.5 feet, and so pi will use 3.14. Now, you can either, class, multiply the 3.14 by 2 to get 6.28, or you can multiply 6.5 by 2, but not both. Does that make sense? You only get to use the 2 once. I would like to use it on the 6.5, because if I double 6.5, I get a nice, easy number. 13. So I'm going to go ahead and multiply here, so I get a 4. You threw me off. Look at you. Making me write a 14, Michael. 13. I correct you, and then I write it myself. Does that make sense? You could do either way, right? But if I make it 6.28 times 6.5, now I got 3 decimal places. If I multiply 2 by the 6.5 and knock out the decimal to get a nice easy 13, just saves me a little work. At your seats. Finish the problem. And we get that the circumference is approximately, class,
40.82 feet.
feet. There we go. 40.82 feet. Approximately that. All right, questions on those? I want you to do 28, 30, and 32. 28, 30, and 32. And on one of these, I would strongly suggest using 22/7. Several people already finished. Just about 30 seconds more to be finishing up. Pencils down. Number 28, give us a diameter of 6 inches. So C equals pi d. How many recognize? You needed to use that. What pi value should we use, class? 3.1. Yeah, no reason not to use just 3.14. Multiply that by the 6. What did you get on number 28, Kirsten?
18.84 inches.
And one more little thing. Is it actually 18.84?
Approximately.
It's approximately 18.84 inches. How many had that for number 28? Look at number 30. They tell us the radius is 7 inches, and as soon as you saw that, class, you should have been thinking what for pi? Definitely should have been thinking 22/7 for the pi. Obviously, we've got the 2, we've got a 7. Realize the 2 is 2 over 1, the 7 is 7 over 1. The 7's cancel cleanly, and then 2 times 22, class, we get approximately 2 times 22.
Oh, do that.
They're both numerators, aren't they? Approximately 44 inches. How many had approximately 44 inches? How many used the 3.14? And you got approximately 43.96. My way was easier, wasn't it? And they're virtually the same answer as well, and they're both approximations anyway. Looking at number 32, the radius it says is 2.5 feet. I'm going to put the 2 and the 2.5 together. I'm going to multiply. What's 2 times 2.5, class? 5. And then we're going to multiply the 5 by 3.14. Yeah, no reason to use 22/7 here. We'll multiply by the 3.14, end up with 15.70, or approximately 15.7 feet. How many had that? Those who made it to number 32. Any questions on how to find circumference? All right, you're going to be practicing this in your homework this evening. I want you to do page 172 to 173. Page 172 to 173. Do numbers 26 to 35. Page 172 to 173, do 26 to 35. And then also on page 171, do 33 to 39. On page 171, do 33 to 39. So page 171, 33 to 39, page 172 to 173, numbers 26 to 35. That's in the homework section. Also, we have a test coming up on Tuesday. Test coming up on Tuesday. That'll be lesson 75 for those watching. Test over chapter 4, coming up lesson 75. That's Tuesday for students in here. All right, when the bell rings, you'll be dismissed. Have a wonderful rest of your day.